Hey students, this is your hints video for lesson 3.4, which is using similar triangles. So for number 11 and 12, I'm just going to kind of walk you through the steps of how you will solve this. I'm not going to give you the answer here. But first, we should be able to solve for this angle right here. If I call it x, we can use the equation x plus 90 plus 51 equals 180 to solve for x. Then, once we know what x is, we can solve for this angle here. I'm going to call it y, and we can do that by saying that x, whatever x might be, plus 102 plus y is equal to 180 because the three angles add to a straight angle or 180 degrees. Then finally, we'll solve for this last angle, which we can call z, and we can do that by saying that y plus z plus 90 equals 180. So that should tell us whether those two triangles are similar. On number 12, we see that we have two intersecting lines, so that creates a pair of vertical angles. So this angle right here should be 29 degrees because it's vertical to the 29 degree given angle. Then we should be able to solve for this angle by doing 88 plus 29 plus x is equal to 180. We can also solve for this angle right here by noticing that those two angles are supplementary. So if we call that angle z, we have z plus 91 equals 180. So hopefully that's enough hints to help you see whether those triangles are similar. All right, this next problem, number 13, we have this treasure map, and it shows the number of steps you must take to get to the treasure, but this last dimension right here is unreadable. That tells us how many steps to get from the pyramid to the treasure. So this is the dimension that we are solving for. So first we need to see, are these triangles similar? And we can prove that by showing that two of the angles are congruent. They both share a pair of right angles, and there's a pair of vertical angles. So therefore, if two of the angles of the triangles are congruent, we can prove that these triangles are similar. So now we need to figure out how we could write this proportion to find the missing dimension. So I'm going to erase what I've got here so we can kind of see. If I took this triangle, the small triangle here, if I rotated it 180 degrees, I would get a triangle kind of like this, so that I'd have them in the same orientation, where this is 80 and this is the angle that I'm looking for. So it might help to kind of see that so that we know which angle or which side length to pair with which side length. So I could write my proportion several different ways. One way though would be 80 over 240 equals x over 300. So that's the 80 degrees or 80 steps to 240 steps is equal to x steps over 300 steps. So solve that proportion and you've got it done. All right, this next problem has this mirror on the ground, and we can see that the mirror is right here in our picture, and it's 6 feet from the lamp post. So I'm going to put a 6 right here. Then you move back 3 more feet, right here, 3 more feet, and we can see the top of the lamp post in the mirror. So you can see that that lamp post is reflecting onto the mirror and going right up into the girl's eyes. So what we want to figure out is what's the height of the lamp post. And I see that the problem I have written here is a little bit different than what you have on your big ideas. What you have is it tells you that you are 5 feet tall, which is certainly helpful information here. So we can tell that we have similar triangles because we have two angles that are known to be congruent, we're told that, and we see that we have two right angles. So we could set up a proportion, and one way we could do that is 3/5, that's the two legs of the small triangle, is equal to 6/x, the two legs of the larger triangle. And solve for x, and you'll have the height of that lamppost. All right, and then this last problem, we have this diagram, and it tells us that the segments BG, CF, and DE are all parallel. So that's going to help us see that some of these angles, like angle CDE and angle BCF and angle ABG, would all be the same. And same thing on the other side, if we have angle DEF and angle CFG and angle BGA would all be congruent as well. So that helps us see that we actually have three similar triangles here. We have triangle ABG that's similar, ACF is similar to that, and ADE is similar to both of the other two. So because we know that those lines are parallel, that helps us prove that our triangles have the same angles and are therefore similar. Now, if we know that they're similar, we can go ahead and solve for some of the missing side lengths. We're told that the length of segment BD, that's this one right here, is 6.32 feet. Now, if we know that, let me erase this so we can see a little bit better. If we know that BC and BD are both the same measurement, then we need to just divide that 6.32 by 2. So that's 3.16. This is also 3.16. And anytime we see that one dash mark, like here, 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 and here, these measurements are all the same. Oops, not 3.6, 3.16. Okay, then we're also told that the length of segment DE is 6 feet. So if this whole length here is 6 feet, then that means that each of these must be 3 feet. Okay. Now, we've already decided that all of those triangles are similar, so we need to find the length of BG and CF. Okay, so here's BG. I'm going to make that yellow. And here's CF. I'll make that one black. So those are the two lengths that we're trying to find. So I'm going to find this yellow length first. And I'm going to say that 3.16, that's this length here, over, I'm going to call this X, this BG, is equal to, and let me use a different color here, this whole length, 3.16 times 3, which is 9.48, over this whole base, which is 6. So that's how we're going to solve for that length BG. Now we can solve for the length CF by doing kind of the same idea. We're going to take this side of the medium triangle, so that's 3.16 times 2, or 6.32, over, we'll call that Y. CF is going to be distance Y. And that we could use the same ratio with the red here that we did before, 9.48 over 6. So solve that ratio and you'll find Y, which is CF.